Hello, class. How are you guys doing? I hope all is well. Before I start, does anybody have any question?
Yes, I have a question, sir.
Please ask.
So for the quiz on Wednesday for chapter one and chapter two, so the if we study only the PowerPoint, is it okay?
Listen, no, it's not okay. I want you to listen. Am I being recorded? Does anybody recording? Yes. Okay, so good question. So, if you just study the PowerPoints, that's not enough because there are times the PowerPoint says one word and I am explaining that one word. So if you study PowerPoints, for example, I will talk about it today, organic, the name of the organic. If I say, what is an organic molecule? In your PowerPoint says organic. And then I talked about organic molecule. Or already lectured on population. I gave you the complete definition of population. But if you look through your PowerPoints, you will not see the definition of population. You see the term, you see the term of population, you see the term of ecosystem, you see the definition of community. You don't see the definitions, you see the words. And then your quizzes and your exam is based on what am I saying? Did I make sense?
Yes.
So it is better, it's best that you study the PowerPoints and listen to the lecture and notes. By the way, the last lecture, it is the lecture from last Wednesday, not Monday of last week. Last Wednesday lecture, if some of you missed it, it is in YouTube also. You know where it is in Canvas. I hope you all know that. It is in Canvas, but you don't want to watch the Canvas. You are better at YouTube. Go to the YouTube and it says the title of the video is Amir and Raven, your textbook, chapter 1. Today's title is going to be Amir and Raven, chapter 2. Do I make sense? And last Wednesday lecture, I talked about chapter 2 a little bit. That is, I didn't say chapter 1 and 2, I said chapter 1. So these videos in YouTube are continuous. If you guys want to go to YouTube and watch them. Do I make sense?
Yes.
Is there any question?
That's all, Professor. Thank you.
All right, no problem. Does anybody have any other question? Okay, if not, let me go over the right here. I think this is where we stopped last time, didn't we? The
Yes.
oxidation, reduction. So let me move things a little bit. Okay, great. During some chemical reactions, electrons can be transferred from one atom to another atom, and that is called ionic bonding. There are 3 different types of bond, and I will talk about them today, I hope. And the one I do not have a time. John, can you bring me my cell phone so I know I can keep track of time? So I will come back to these PowerPoints, but again, let's talk about it right now. When electrons are transferred from one element to another element, it is the electron that is transferring, the name of the process is called oxidation reduction. The name of the electron that is receiving is called, the process is reduction. But I know it can be confusing, and I'm sorry about that. The name of this atom is called a reducing agent. The name of this atom is called oxidizing agent. And I will get to it. I hope you will see it throughout the semester, and hopefully we'll talk about it. So remember, we talked about this. In the first shell, there is only 2 electrons. In the second shell, there are 8 electrons. All of those dots, you learned this in bio, you learned this in Chem 3A. There are 8 electrons. And in the last shell, there is only 1. So if sodium loses that 1 electron, it becomes happy. It becomes 8. All of the elements are trying to have 8 electrons in the outer shell. Chlorine, on the other hand, has 7. It loves to have 1 more electron in its outer shell to become 8. And that's what happens. So sodium transfer 1 electron to chlorine. Now chlorine has 8. Sodium has 8. They both are happy. Do it make sense? And that kind of transfer of electron to another element is called ionic bonding. I hope you guys know what I'm talking about. If you don't, please ask me in the lecture or lab. Since sodium gave away, put it this way, gave away an electron, it is positively charged. And chlorine received an electron, is negatively charged. Okay, so chlorine was in a hole, let's say negative, and sodium, it has a lot. It's positive. It can give away. Okay, put it this way. Elements, periodic tables display elements. I'll show you in a picture. Valence electrons. Valence electrons, number of electrons in outermost layer level. That's what the valence electron means. It means on an outer layer, the most outer layer, how many electrons are orbiting, how much room they have for how many electrons from another element. You'll see not all elements transfer electrons. Some of them share electrons. Some transfer, some share. Okay, then inert, it means non-reactive elements have all 8 electrons for, like natural gases, neon. Okay, it has helium. It has the outer layer has 8 of them. I'll show you in a picture. Octet rule, it means atoms tend to establish completely full outer energy level. Let's talk about this. Okay, this is what I was talking about. Okay, I'm sorry, these are neon, argon, and all of these gases, they have complete 8, they call them neutral gases. They have complete 8 electrons outside of them. I hope I'm making some sense. This one, fluorine, chloride, iodine, bromine, they all have 1 electron lacking outside of, they have 7, put it this way. They have 7 electrons outside of them. Oxygen, all of these have 2, lacking 2. This one have 3, and of course, carbon, the backbone of life on planet Earth, has 4. Okay, I hope I'm making some sense. So in chemistry, you memorize you memorize the abbreviations and number of the valence, everything else. Not here, not for this class. Of course, these are the ones I would like because we do need them. Oxygen, abbreviation of oxygen is O, carbon is C, hydrogen is H, nitrogen is N, sodium is Na, chlorine is Cl, calcium is Ca, phosphorus is P, potassium is K, sulfur is S, iron is Fe, and magnesium is Mg. There are a few more I would like you to know, but pretty much for this class, these are the main ones we need to know. Okay, Any question? If you have any question, please unmute yourself and ask. Okay, so the elements in periodic, that is a periodic table. This is periodic table, you guys, right here. Most everything I'm saying, you had it in chemistry 3A. But anyhow, let's move. There are 90 naturally occurring elements. Yeah, it would be good to know those numbers, but I try not to ask for any specific numbers. Only 12 elements are found in living organisms in substantial amount. 4 elements make up 96.3% of the human body. Yeah, and that is important. I will not ask for the number, but what are the 4 elements pretty much make up our body? Most of our body: carbon, hydrogen, oxygen, nitrogen. And you will see that in chapter 3, where they are, how they are located. Okay. Organic molecules contain primarily carbon, hydrogen, oxygen, nitrogen. No. Yeah, well, yeah. But what is the definition of an organic molecule? Your textbook did not give it to you. I am giving it to you, and it's going to be in your quiz on Wednesday. So organic molecule are molecules that have carbon to carbon bond, covalent bond. Of course, I haven't talked about covalent bond yet. They have carbon to carbon covalent bond or carbon to hydrogen covalent bond. Have you heard of the element, based on that definition I gave you? Have you heard of the element, the molecule carbon dioxide? You've heard of that. The Mother Earth is suffering from too much accumulation. Is carbon dioxide organic molecule? Anybody? No. Why not? Because it's not carbon to carbon or carbon to hydrogen. CH4, methane gas. It's also on the surface of the Earth, on the atmosphere, causing a lot of problem for us. Methane is CH4, C1 carbon and 4 hydrogens around it. Is that a organic molecule? Yes. Based on the definition I gave you, organic molecule is carbon to carbon or carbon to hydrogen. Some trace elements are in trace elements. It means elements that are in a small amount, very small amount found in our body, a very small amount, such as iodine in our thyroid, and of course in the hormone thyroxine percolating in our body. Chemical bonds, molecules are grouped of atoms held together in a stable association. Compounds are molecules. It's giving you the definition of molecules containing more than one type of element, like water. It's more than, it's hydrogen and oxygen as a compound. And then atoms are held together in a molecule or compounds by chemical bonds. Okay, the first bond, already talked about this a little bit for you guys, is ionic bond formed by attraction of oppositely charged ions, gain or loss of electrons for some ions. And sodium, we already talked about that, loses electron, becomes positive, becomes a cation. So sodium is a cation. Chlorine is an anion because it gains electron. And then opposite charges attract so that sodium and chlorine remain associated as an ionic bond. And what can break that ionic bond? Water. You take some salt and put it in water, right? They break apart. Okay. Electrical attraction of water molecules can disrupt forces holding this ion together. Here we go. So we talked about this a little bit. Sodium is oxidized but it is a reducing agent. I would like, this is good. This textbook talks about it from early on. It is good because we need it. And then chlorine is reduced, but it is oxidizing agent. And then when chlorine and sodium chloride are together, they're like this. So this is, they are both, the sodium lost its electron and gave it to chlorine. So now sodium is Na plus. And chlorine, it is Cl minus. So chlorine is an anion and sodium is a cation. And they are together like this. The crystal, sodium chloride crystal, the salt, the natural salt that you put in your food. Natural salt, not the salt that is synthetically organized in a laboratory. No, I'm not talking about those. Okay? So covalent bond, the next one, the next type of bonding. See, you have a bond between you and your wife. It's a marriage bond. You have a bond between you and your brother or your sister. It's a different type of bond. I hope I'm making some sense. Same as elements. They form different kind of bond among themselves. So what is covalent bond? When two share two or more valence electrons. When they share two or more electrons, 2 or 4 or 6. And usually happens with carbon and hydrogen. Molecules such as H2 are stable because there is no net charge. Octet rule is satisfied. They both have 2 electrons orbiting outside of each hydrogen. Okay, and there are no unpaired electrons. Yes, there is no single one, just like sodium. You saw a single one orbiting outside of it. You know, the first shell, everything is full. Strength of covalent bond depends on the number of the shared electrons. Many biological compounds are composed of more than 2 atoms, may share electrons with 2 or more atoms. Let's look at them. Okay, here's hydrogen. That's what you saw, H2. You were rare, for biochemistry part 1, I would expect you to draw these like that. And then, of course, for rest of semester, we see them like this. This, you know, you don't, it makes you don't have to draw them anywhere, or I will not draw them and ask you to name them, so on and so forth, but be familiar with them. Oxygen. I wish I had a pen to draw, but oxygen normally, it has 2 electrons in the first shell and it has 6 electrons in the second shell. So it can share how many more electrons to become 8? 2 more. So with another oxygen, and you write it down like this, 2 covalent bond, 1 covalent bond, 3 covalent bond between nitrogen. So oxygen, they are sharing 4 electrons, and it indicates by 2 lines. 2 hydrogens are sharing only 2 electrons and indicating by 1 line. I hope I'm making some sense. And then, of course, 2 nitrogens. Nitrogen has 5 electrons. 2 in the first shell, 3 in the third shell. So this hydrogen also has 5 electrons. 2 in the first shell and 3 in the third shell. And those will share electrons to become 8. 1, 2. Let's look at this nitrogen. How many electrons orbiting outside of this nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. How many electrons orbiting outside of this nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. How many electrons orbiting outside of this oxygen? 1, 2, 3, 4, 5, 6, 7, 8. So this type of bonding, when elements are bound to each other that way, that is called the covalent bond, sharing electrons. Electron negativity is atoms' affinity for electrons. Differences in electronegativity dictates. The best example I have for water, so you will see that here in a minute. Non-polar covalent bonds equal sharing of electrons. Polar covalent bonds unequal sharing of electrons. Let's see, do we have any examples? No. Okay, but anyhow, chemical reactions involve the formation of breaking of chemical bonds. Yes, yes, yes. Atoms shift from one molecule to another without any change in the number of identity of reactants. Okay, the main thing in here, you guys, on this PowerPoint, the main thing I would like you to know that you know these two are reactants. And then these two are the products. When you combine water and carbon dioxide, photosynthesis, the process of photosynthesis, it makes glucose molecule. This is a product of photosynthesis and of course oxygen. What goes into photosynthesis? Water and carbon dioxide. You already know these things from high school, from other classes. So these two, what goes into photosynthesis is called reactant. And what comes out of photosynthesis is glucose molecule and water. Okay, the extent of chemical reactions influenced by temperature. Yes, concentration of reactants and products. Yes, catalysts, which in biology are enzymes. What are catalysts? Have you studied that in Chem 3A? What is a catalyst? Anybody?
A catalyst is what speeds up a reaction.
Very good. In chemistry, a catalyst is a chemical that speeds up chemical reaction, but it is not involved in that chemical reaction. It does not change at the end. And in biology, we have enzymes. Enzymes are called biological catalysts. Okay? And many reactions are reversible. Yes, yes, yes. So the chapter is moving into the water. That is fine. So it did not give us that's fine. I hope, we'll see if there's hydrogen bonds in here somewhere. I hope there is. If not, I will talk about it sometime. Life is extremely tied up with water. Some single outstanding chemical property of water is ability to form hydrogen bonds. Aha, I told you so. Weak chemical associations that form between a partially negative oxygen atoms and partially positive hydrogen atoms of the two water molecules. Okay, let's reflect back a little. 3 types of bonding you learned so far. Ionic bond, covalent bond, hydrogen, and you will see, I will talk about hydrogen bonds more. But among these 3, the weakest of the 3 is hydrogen bond. So you see how am I doing this now? I am talking about these videos. And then quiz on Wednesday, I will ask, what is the weakest of the following bonds? See, it's not nowhere in your notes. Well, it says weak chemical reactions. But I said the weakest of the 3 is hydrogen bond. And then the strongest of the 3 is covalent bond. It means if you want to break a covalent bond, you have to spend a lot of energy. You want to break a hydrogen bond, Not much. It breaks. Am I making sense, everybody? So you have a question? You're unmuting yourself.
No, sir.
So, okay, let's move on. And then polarity of water, let's talk about it. Within a water molecule, the bonds between oxygen and hydrogen is highly polar. What does that mean? It means you have a molecule of hydrogen here, oxygen here. These three ends are positively, and one molecule, one compound, you like to call it one compound, H2O. One end of it is negatively charged, the other end is positively charged. That's called a polar molecule. Oxygen is much more electronegative than the hydrogen. So the partial electrical charges of oxygen is negative, and hydrogen, you have two of them, is positive. Let's look at the picture. Here we go. Finally, pictures. So here is oxygen, 2 electrons in the first shell. Then 6 electrons in the outer shell. 1, 2, 3, 4, 5, 6. It has room for how many more electrons to become 8? 2. Where do they get it? From 2 hydrogens. Hydrogen, each one of them has 1 electron outside of it. So now hydrogen is happy because he has 2 electrons outside of it. Hydrogen is happy because he has 2 electrons outside of it. Oxygen is very happy. He has 8 electrons outside of it. Okay, do not worry about 104 degrees, but anyhow, but as long as you know oxygen is electronegative, and hydrogen is electropositive, just like that. Hydrogen are positive. So this molecule, because one end of it, this is a molecule, one end of it is positively charged and one end is negatively charged. This molecule is called a polar molecule. Not all molecules are like that. Okay. So hydrogen bonds, now we are getting to the hydrogen bonds. A cohesion, polarity of water allows water molecules to be attracted to one another. Yes. That's why mosquito can walk on the water, because water molecules are attracted toward each other. They have a weak bond between them, which is called hydrogen bond. Okay, attraction produces hydrogen bonds. I show you some pictures. I hope I have some pictures. Each individual bond is weak and transitory changes, and cumulative effects are enormous. Yes, as a result, you can walk on the water. As a result, when you jump from Golden Gate Bridge down, water is very smooth, but you go down, you die. The person dies. It's like hitting a hard rock. Have you ever known people that commit suicide from Golden Gate Bridge? They have put fences up there now. People don't do that because when you jump in that water, they form, even though it's weak, but from high elevation. Have you gone swimming from diving board? You go with your stomach and your stomach get hurt, or you don't dive properly, you get pain. Anyhow, responsible for many water's important physical properties. Here we go. This is a hydrogen bond. Are you ready for this? Are you guys ready for hydrogen bond? So here's oxygen. Here is hydrogen. The hydrogen of this, it is positively charged, is attracted. They have an attraction. It's not physical bond, just like you learned with ionic bond and covalent bond. Ionic and covalent bond are like this. This is an attraction. They're attracted toward each other. Do you guys know the difference now? I talked about it. Since there is an attraction, and as I said, it's a very weak bond, it's called hydrogen bond. Of course, hydrogen bonds need what? They need hydrogen. I want to say in the quiz question, I want to say which of the following is not characteristics of hydrogen bond? Well, hydrogen bond needs hydrogen. It's a weak bond. It is between two compounds that they have hydrogen. Well, at least one of them has hydrogen. Of course, this water molecule does not have. It's not, the hydrogen is facing the oxygen of this one. It has hydrogen, but it's on the other side. The oxygen is negatively charged. Hydrogen is positively charged. They are attracted toward each other. Anyhow. So here is a hydrogen atom, hydrogen bond, and oxygen atom. That's what I was talking about. An organic molecule. Okay, organic molecule, these are all carbon. He's giving you organic molecule, but your textbook is not giving you the definition of organic molecule. Organic molecule is a molecule that has carbon to carbon bond or carbon to or carbon to hydrogen bonds. You will see a lot of it later on. Here's a mosquito that I was talking about that can walk on the surface of the water just because of those hydrogen bonds. Adhesion, very small capillaries, the water is elevated higher. Water molecules stick to other polar molecules by hydrogen bonds. Yes, cohesion, water molecules stick to other by hydrogen bonds. Okay, properties of water. Water has a high specific heat. Yeah, a large amount of energy is required to change the temperature of water. Yes, as you know, water has a high heat of vaporization to become steam. The evaporation of water from a surface causes cooling of the surface. Solid water is less dense than liquid water. So ice, okay, solid water is ice. Bodies of water freeze from the top down. Okay, salt dissolving water, hydrogen sphere. Did they make? Yes, hydrogen. She's talking about hydrogen shells. It's okay. So what happens, as I talked about it a little bit earlier, when you add water to salt, you grab a cup and you put salt in there and you put water in there and you stir it, what will happen? Sodium separates from chlorine. And then guess what? Who is surrounding it? Water molecules. And then this shell of water around sodium, the shell of water around chlorine is called hydration shell or hydration sphere. I've seen both of them. Shell or sphere. Okay, here's the water molecules. I already talked about that. Make sure you know these things. I'm talking about it. So I am talking about them and I'm hoping you take notes. And then you quiz your exam. Any question in there that I did not talk about it, you show it to me. Say, Amir, I watched the videos. You didn't talk about this. I give you credit. Everything I say, everything you quizzes, I did talk about it. Okay, water is a good solvent. It means water is called universal solvent. What is universal solvent means? It means a lot of things can be dissolved in water. That's why water is called universal solvent. So what is a good solvent? Things can be dissolved in water. Water dissolves polar molecules and ions. Water organizes non-polar molecules. Hydrophilic, it means water-loving, and hydrophobic, water-fearing. Phobic, you learn it in your root words. It means dislike, fear. Philic, love with the L. If you get the two terms confused, look at the L. L in here, it means love. Phobia, you've heard of phobia all your life. You know what phobia means. You dislike. Claustrophobia or something, hydrophobia, zoophobia. You've heard that a lot in your life. Water causes hydrophobic molecules to aggregate or assume specific shape. Yeah. Hydration shell. Water can form ions. Yes. This is an ion now. A cation. Anion. Okay, pure water is hydrogen of 10 to the, it has concentration of 10 to the minus 7, considered to be neutral, pure water, and neither acidic nor basic. pH is a measurement percent hydrogen. pH stands for percent hydrogen. So a pH is negative logarithm of hydrogen ions concentration of solution. Those of you who had chemistry, you work with the logarithm. Anyhow, acid, any substance that dissociate in water to increase the hydrogen concentration, hydrogen ion concentration, and lower the pH. I'll show you a chart in a minute. The stronger an acid, the more hydrogen ions. The acid in your stomach, it's very strong. You put your finger in there and you grab the acid of your stomach, you put it in a beaker, and you put your finger in there for 5 minutes, you remove your finger, there is nothing left but bones. That's how strong your acid of your stomach is, okay? Base, substances as combination with acid dissolve in water and thus lowers the hydrogen concentration. Here we go. So 7, as we said, is neutral. Anything below 7, 0 to 7 is acidic. Here are some examples. Your urine is acidic. Coffee you drink is acidic. Tea we drink is acidic. Tomato, vinegar, as you see, cola, beer, stomach acid, as I said, pH of 2, very strong acid. Hydrochloric acid, very strong acid. I work with hydrochloric acid in the lab, the strong one. Of course, the different concentrations, the different percentage, but I did work with a very strong hydrochloric acid. Anyhow, the base, on the other hand, seawater. It's a base. Baking soda. Great Salt Lake City, household ammonia, household bleach, and sodium hydroxide, NaOH. You probably work with it in the lab. These are all examples of base. Okay, buffer is a substance, is a solution, if you would, that the change of pH, it takes a while. It doesn't change quickly. It takes a while to change the pH of that. Substance that rises, the changes in pH act by releasing hydrogen ions when a base is added, absorbing hydrogen ions when acid is added. It means they do not change much. They're buffer. Okay, overall effect, hydrogen constant relatively constant. Yeah, right here. See, there is an area buffer range. Okay, anyhow, let's move on. Biological buffers, most biological buffers consist of pairs of molecules, one an acid and one base. Water and carbon dioxide gives you carbonic acid, which is bicarbonate, and hydrogen ions. These are all good examples. I don't have much to say about those, and that's the end of the chapter. Let me check the time, and then I will continue with chapter 3. It depends on what time we have. Hang on. Let me find my cell phone. Oh, I got it. I got it. 209. Okay. Okay, guys, it is 2:09, so we can go ahead. Let me stop. No, it doesn't like that. Okay, can you guys? Okay, great. Let me start with chapter 3, the last chapter in your for your exam, but it takes a while. It has a lot of information, as I said, a good amount. Your quiz, let's say, okay, good question, Saul. Your quiz on Wednesday is chapter 1 and 2, and whatever I talk about on chapter 3. Okay, everyone? Okay. Does anybody have any question? Great. So this is chapter 3, guys, which we are going to spend the rest of our time this week and next week on chapter 3. And then hopefully by the end of Wednesday, next week, you are ready for your first exam. Okay, if nobody has this chapter, we talk about carbon, carbohydrates, nucleic acid, proteins, and lipids. And these are the macromolecules or building blocks. I like the term building blocks. This textbook that we are using uses that term. The last textbooks I used did not use that term, which is okay. But I use it, and that's the one I want you to be familiar with. Macromolecules or building blocks. Okay, please go up. Please go up. Anyhow. Oh, you went up. Okay, modern biochemistry. You remember on Wednesday, you're going to hand in metric system. And then next Wednesday, you must hand in your biochemistry part 1. And the answer to those questions are from this chapter. Everybody knows what I'm talking about. Okay, modern biochemistry studies biological molecules outside of the cells, classes of biological macromolecules or building blocks, carbohydrates, lipids, proteins, nucleic acids. Those 4 you should be familiar with for the rest of semester. You have to know them. I show you a molecule in your next exam, exam number 1, you should recognize it. It's a carbohydrate. It's a lipid, Amir. It's a protein. It's a nucleic acid. Here they are again. Your textbook is going over, giving you some very interesting experiments. Please read them. Carbon, the framework I talked about of biological molecules is carbon. Our backbone, our life on planet Earth is based on carbon. Living organisms, I mean living organisms on planet Earth are based on carbon. Very significant element. Okay. Framework of biological molecules consists of primary of carbon bonded to another carbon or oxygen or nitrogen or sulfur or phosphorus or hydrogen. That is a great thing about carbon. It can bond to different things and form a covalent bond, strong bond. Not James Bond, you guys. I'm not talking about James Bond. You guys go watch those movies. The last episode, he died. I don't know. He's going to come back from death or Hollywood replace him with another Bond. But anyhow, can form up to 4 covalent bonds. Yes. More than anything else. More than hydrogen. More than oxygen. More than nitrogen. 4 covalent bonds carbon has. That's a great property. Okay, hydrocarbons, molecules consisting of only carbons and hydrogens, they are non-polar. Remember non-polar? It means one end of molecule is not negative and the other end of molecule is not positive. What is an example of polar molecule you learned today? Water. What is an example of non-polar molecule you learned today? Carbohydrates. Sugar. Sugar is non-polar. Okay, functional groups are specific, very important. You should know them. Bound to carbon, hydrogen, and cores. Each group has unique chemicals, properties. Properties of functional groups are retained wherever they attach and influence behavior of entire molecules in reactions. Right here. I would like you to know those. The OH at the end of a molecule, the OH is a hydroxyl. And then carbohydrates gives you found in examples. Okay. Carbonyl, they have acetaldehyde. Carbohydrates, nucleic acid, they have a OH, C double bond, oxygen with oxygen. They have carboxyl, they are acid. The carbon, double bond O and OH on the other side, the other end. Proteins, lipids. Okay. And they're different. Make sure you know the difference between the two. Carbonyl and carboxyl. Amino group, easy to recognize, to remember. Nitrogen and 2 hydrogen attached. Sulfurhydryl, it has a sulfur and a hydrogen attached to it. Phosphates, so you have like ATP, nucleic acids, some of them. And then you have methyl group, they have CHHH. There are a few more, your textbook did not mention them, that's okay. But make sure you know these 1, 2, 3, 4, 5, 6, 7. These 7, make sure you know. If you want to make flashcards, make flashcards, or whatever you have to do it. Because you do need that for the rest of semester. Anyhow. Isomers, molecules that have same molecular or empirical formula, C6H12, O6. C6 glucose molecule, but they're isomers of each other. Structural isomers differ in structure of carbon skeleton. Stereoisomers different in how groups attach, enantiomers, chiral, 4 unique groups attached, and mirror image molecules right here. Your hand is an enantiomers. It means the 2 molecules are mirror image of each other. 2 different properties they have. They're completely different, but they're mirror image of each other. Things you can do with your right hand cannot do with left hand. In my case, I cannot brush my teeth with my left hand. They're mirror image of each other. Okay. So macromolecules, polymers built by linking monomers. Monomers are small, similar chemical subunits. So I would like you to know this table. Make sure you know it, study it. Start studying this table from now. So you'll be ready for your exam, for your quiz. Anyhow, so get ready for it. And then I will talk about each one of these. I'm not going to talk about, because you get bored, you get lost, so on and so forth. But that's what the rest of this chapter is all about. Carbohydrates, nucleic acid, proteins, and lipids. So the carbohydrates and nucleic acids are macromolecules. Why he's combining them together, that's okay. So glucose molecules, starch, is made up of monosaccharides. Oh, he's telling you what is the difference between a monomer and a polymer. A monomer is a single unit. But look, this single unit is repeated in this polymer, in starch. Same as this one. This is same as that 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 one, and so on and so forth for the rest of it. So this is a poly. Poly means many. Are you studying your root words? There are going to be questions on Wednesday on your root words. Poly means many. Monoid means one. One similar unit. Many of that same unit. Okay. Mono, it means nucleotide, and they are attached to DNA molecule, where DNA is found in chromosomes, where the starch found in chloroplast. So now you do know what is a monomer, single unit, and what is a polymer, repeated units. It depends what molecule you're talking about. They didn't mention protein, but protein, a monomer for protein, right? They mentioned starch and DNA, but it would be protein here is a polymer, and the monomer is amino acid. Okay, you guys. Oh, shoot. I skipped what? It does not want to stay on that one. Okay, proteins and lipids. Okay, we talked about this. Really, the lipids do not have they do not have monomers, but proteins they do. Okay, I'm going to stop right here, and your quiz stop right on polymers and monomers. How about that? Does anybody have any question? This video is going to be on YouTube under Amir and Raven chapter 2. Even though I talked about chapter 3 a little bit, but it's chapter 2 mainly. Does anybody have any question? If not, I'll see you on Wednesday morning at 8:30. Is that right? First thing you do, you hand in your lab report on metric system. Second thing you do the lab on biochemistry part 2, not part 1, part 2. Bring and print biochemistry part 2. And then we have to do the lab, and then you're done. At the end of the lab, we have that quiz. All right. Sayonara, guys. See you later.